Out past the overgrown apartment blocks of Pripyat, a colossal steel arch dominates the horizon. This is the new safe confinement. It stands 108 meters tall, weighs 31,000 tons, and required 2.1 billion euros to construct. When it was pushed into place in 2016, it came with a singular mission: to serve as the ultimate, impenetrable tomb for the remains of Reactor 4 for the next 100 years. That century-long promise lasted less than a decade. On February 14, 2025, a low-cost weapon plunged out of the sky and crashed directly into the roof of the megastructure. The weapon was a Russian Shahed-136 drone. Its explosive warhead detonated on impact, blasting a 6-meter-wide hole straight through the roof of the containment shield. Local emergency services extinguished the resulting insulation fires within hours. When they checked the sensors, radiation levels outside the structure remained entirely normal. Analytical, local radiation levels stayed within safe parameters, yet the IAEA officially declared the building had lost its primary safety functions, treating a localized fire as a global nuclear emergency. Understanding why the structure failed requires looking past its role as a weather shield. The arch functions as a massive, specialized laboratory built to support a decades-long internal dismantling operation. The primary tools for this operation are two massive 84-meter bridge cranes suspended directly from the ceiling of the arch. These cranes have a critical job. They are used to remotely deconstruct the unstable, hastily poured concrete sarcophagus from 1986 that rests right beneath them. Taking apart an actively radioactive ruin requires extreme precision. The internal environment has to remain completely stable for decades to protect both the delicate crane equipment and the human operators running them. The arch is a specialized industrial facility. Its success depends on its ability to actively process the radioactive waste, not simply isolate it. Operating this environment introduces a massive engineering hurdle, keeping a completely enclosed steel structure from rusting away from the inside out over a century. This cross-section shows the architectural solution: two separate walls creating a gap between the outer layer and inner polycarbonate panels. Warm, dry air pumped at 50 pascals creates a pressurized barrier against moisture. The drone explosion punched through both layers. The pressurized air immediately escaped, equalizing with the outside atmosphere. The physical breach was only the start of the damage. The resulting fire destroyed internal insulation, and the blast critically damaged the main crane system equipment. The system experienced a cascading failure. Without pressure, climate control fails. Without climate control, cranes halt. Without cranes, dismantling stops entirely. A single hole in the roof effectively neutralized the entire multi-billion-dollar mission. It stripped the facility of the stable environment it requires to actually do its job. Today, there is an international scramble to secure the compromised megastructure before the internal machinery degrades further. The European Bank for Reconstruction and Development has authorized a $30 million fund strictly to study how to begin fixing the hole. The long-term financial stakes are immense. Actual structural repairs are currently estimated to cost upwards of 500 million euros, and that work will not be completed until at least 2030. The initial promise was 100 years of guaranteed safety. In reality, the structure suffered a catastrophic systemic breach less than a decade into its operational lifespan. It is tempting to believe a nuclear incident ends the moment the concrete sets and the initial shield is built. Chernobyl remains an active, unending crisis. Permanent nuclear containment requires massive continuous funding, uninterrupted human intervention, and absolute geopolitical peace, elements that a single drone strike proves we can no longer guarantee.